Yeah, question 2. I think we need to be drawing a little diagram to help us out. And, well, it is 3D, but we're going to draw a little kind of 2D representation of it. It's a parallelogram, okay? And we always, when we're labelling these things, we go in order. It doesn't matter whether we go anti-clockwise or clockwise around it. Let's just draw a parallelogram. Just roughly, it doesn't even need to be a great parallelogram. And so there is O, A, B, C. It's what?
I thought it was 3D.
It is 3D, but that, you know, we're just thinking of it, we're looking along the plane that it's in, because it must all be in the same plane somehow, not necessarily an X, Y, or Z plane. So these are the points. Obviously that's 0, 0, 0, we've got that one as 282, 558, 3 minus 3, 6. And I think the reason we need to draw the diagram is the question then says, use a scalar product to find the acute angle between the diagonals of this parallelogram. Well, the diagonals of a shape are when you join opposite corners. So they are the diagonals there. And so the acute angle between the diagonals, well actually at this we don't really know yet which the acute angle is going to be, do we? Because I've drawn the parallelogram like that, but it may have been a squashed parallelogram that way, you know, and that determines which of these two angles that we've got is going to be the acute angle. So let's just find the angle between them. And it seems sensible. Well, we've got the vector OB already. That's that vector there, because that's the point B. So let's find the vector AC, and then that will give us that angle, won't it? It's the angle between the two vectors as they depart. So we'll work out that angle. If it's acute, brilliant. If it's obtuse, we'll take it away from 180 and we'll be sorted. So we have the vector OB already, that's given in the question. It's the vector 558. The other vector is the vector AC, so let's work that out. And AC, that involves going from A to the origin and then to C. So A to the origin is minus the vector 282, and the origin to C is the vector 3 minus 3, 6. So before we do anything else, we need to work out that vector as being, what is it, minus 1, minus 11, 4. I think that's a plus 1. 1, minus 11, 4. Okay. So now we've got the two vectors that we need to do our scalar product-y thing with. Scalar product says that A dot B is magnitude of A, magnitude of B times the cosine of the departing angle in between them. So if we rearrange that, we've got that the cosine of theta is the dot product of our two vectors, which remember are this vector and this vector. So the dot product of 558 and 1 minus 11, 4, divided by the product of their two magnitudes. So 5 squared plus 5 squared plus 8 squared, and this one is 1 squared plus minus 11 squared plus 4 squared. And remember how we work this out, we're going to do 5 times 1 minus 55 plus 32 down there, and then this gives us, I can't remember what this is, root 114, and this must be, is it root 138?
Yeah.
Right, do anybody have this? So we end up with, what have we got there, 37, so that's 18. Is that minus 18? Over that. That's what cos theta is. Look, I've got the wrong angle, haven't I? Because this is negative. If cos is negative, it's going to tell me an obtuse angle. So I'm going to stick that into my calculator, and that will give me the angle. It gives me the angle of 98.25 degrees. So, you know, my diagram wasn't quite right. It wasn't a long, thin a parallelogram, it was a short, kind of tall parallelogram. It was that way. So the obtuse angle was the other one. So the acute angle was the other one. So my acute angle is 180 minus 98.25 degrees, which is 81.7 to 3 significant figures. And there we are. Unfortunately, when it came to the mark scheme for this, you started with a mark for getting the vector 1 minus 11, 4. And then you got a method mark for doing the scalar product of your found vector and the other diagonal. So that that had to be a diagonal thing rather than the scalar product of two of the sides. There were quite a few special case marks for getting an angle from choosing two of the wrong vectors to do it with. And so there was either special case of 2 or special case of 1. If you got special case of 2 if you found an acute angle of 2 incorrect vectors, and a special case 1 mark if you found an obtuse angle correctly from 2 incorrect vectors. So a few of you picked up 1 or 2 marks, but that's some way off the 5 that you should have got for doing that. You could...
Wait, AC is it down?
Yeah, we've used AC. Did you work it out correctly then? Right, do you want to stop the video, Jolie?